Good day, sir. We're here to explain or discuss to you our chosen algorithm, which is the top K elements algorithm. But before diving into specifics of what is written in our manuscript, I'd like to provide some background of our chosen algorithm, which is the top K elements algorithm. So for introduction to top K elements algorithm in definition, the top K elements algorithm efficiently retrieves the K largest or smallest element from the dataset. So in so the top K elements algorithm is crucial in scenarios where quick and efficient extraction of the most significant data points is required. And also, it finds application in various fields. First is the data analysis, second is the stream processing, and third is the information retrieval. In data analysis, it helps in identifying top performing metrics or K influencers. In stream processing utilizes this algorithm to handle real-time data flows and ensuring timely decision making. Then last is the information retrieval. In information retrieval, it aids fetching the most relevant documents or search results, enhancing user experiences. Now, let's proceed to our historical contributions and development, or the historical contributions and development of our chosen algorithm. First is Misra in Greece in 1982 rather. It is proposed an efficient algorithm for approximate computations of top K elements. Or Misra in Greece laid the foundational work in 1982, enabling approximate solutions which are faster and requires less memory. Then second is Greenwald and Khanna in 2001. Introduce further refinements to improve efficiency and accuracy. Greenwald and Khanna's contributions in 2001 or 2001 built on this foundation, offering enhancement that balance and speed precision. In conclusion, for the historical contributions and developments, these historical advancements have spurred continuous improvements, leading to more sophisticated algorithms and data structures tailored to various challenges in the top K elements problem. The next list, let's proceed to the slide of overview of the top K elements algorithm or overview of our chosen algorithm. For the purpose, this algorithm purpose is efficiently identifies the K largest or smallest elements from the dataset. Or the primary goal is to quickly find the most significant element in dataset, whether they are largest or the smallest. The next is the K data structures, which is first is the heaps and the second is the priority queues. For heaps, it is useful for the dynamically keeping track for the top K elements as they allow efficient insertion and deletion. Then for priority queues, it helps in maintaining the order of elements, ensuring quick access to the smallest or largest element. Then next is the process. First is it is iterates through collection. Second is it compares current element with smallest element to the largest element in the top K set or in the given top K set. Then third is the updates top K set accordingly. Or in conclusion, for process is the algorithm or our chosen algorithm continuously compares each new element with the current smallest or largest in maintained top K set, ensuring that set is always updated to reflect the top K elements. Then next is the optimization, which have first is retains only top K elements, and the second is optimizes time and space complexity. So by optimization, by only retaining the top K elements, the algorithm or our chosen or this algorithm minimizes both the time spent on comparisons and the memory use, making it efficient for large data sets. So the next slide is the time complexity of top K elements algorithm or our chosen algorithm. And big O notation, time complexity of our chosen algorithm is 0, open parenthesis, n, lag, then k, then close parenthesis. I don't know if I pronounce it correctly or I read it correctly, but I read it as 0, then open parenthesis, and then lag, k, then close parenthesis. This time complexity is derived from the efficiency of heap operations combined with the need to iterate through the entire input array. Then the time complexity have components. First is the n, which means size of the input array. Then k means the number of top elements to be found. It is emphasizes the importance of n and k in determining the algorithm's performance, highlighting that larger input sizes and smaller k values are efficiently managed by this approach. Then next, for the data structure, it min heap means maintains the k largest elements and ensures efficient updates, or the use of min heap is crucial as it allows for maintaining the dynamically updated set of the top k elements with minimal overhead. So the next is, let's talk about the heap operations and efficiency. So for heap operations, there are two operations. First is the insertion and second is the deletion. Both insertion and deletion have same time complexity of O open parenthesis, lag, K, then close parenthesis. These heap operations are efficient with both insertions and deletions having time complexity of O open parenthesis, lag, K, and close parenthesis. And then for the next is for the process. First process is iterate through input array. Second is compare each element with the smallest in heap. And third is update heap if current element is larger. So during the alteration through the input array, each element is compared with the smallest element in the mean heap. If an element is larger, it replaces the smallest element and the heap is adjusted. This iterative process ensures that any point of the heap contains the k largest elements encountered so far, optimizing the search and extraction of top k elements. So before ending with my discussion, I would like to introduce myself. Again, I'm Rhea Patigas. Then for the next slide, it is presented or discussed to you by my groupmate, which is Giselle Batingal.
Real-world simulation, analyzing ride-sharing destinations. For the use case, analyzing most popular ride-sharing destinations in a metropolitan area. So the algorithm is utilized to simulate various conditions affecting ride-sharing, helping to pinpoint the most in-demand destination. Applications, typical weekday traffic patterns, special events, adverse weather conditions, road closures and alternate routes, public holidays. By simulating different scenarios, the algorithm helps understand how factors like weather or events impact ride requests. For the tools, Python along with visualization libraries like Matplotlib and Seaborn are used to conduct and visualize this simulation. Then the goal is to identify top K most popular destinations, optimize ride-sharing services, validate algorithms' practical utility. So the primary objective is to identify top destinations for rides, enabling better resource allocation and service optimization, demonstrating the real-world applicability and benefits of the top K elements algorithm in enhancing ride-sharing benefits. Test cases for dynamic scenarios. Scenario 1. Rush hour traffic. Sudden surge in popularity leads to delays and congestions. So the algorithm adapts to increased demand during peak times, ensuring that the top destinations reflect current traffic conditions. For the scenario 2, unexpected road closures causes traffic diversions, alters traffic patterns. So the algorithm quickly recalibrates to account for new traffic patterns caused by closures, maintaining accurate top K destinations. For the scenario 3, event causing diversions, accidents, parades, construction work, and changes in traffic routes. So by incorporating real-time data on events that impact traffic, the algorithm adjusts to reflect changes in traffic routes, providing relevant top K destinations. Results and observations. Robustness and reliability. Consistently identifies top K elements, effective in dynamically changing environments. So the algorithm's strength lies in its consistent performance, similar to finding shortest path in a graph, ensuring that top K elements are accurately identified even under dynamic conditions. The real-world scenarios handles uncertainties and fluctuations in data. So its ability to adapt to changes, such as those in traffic patterns or during unexpected events, highlights its practical utility. Resilience and accuracy. Maintains accuracy despite evolving condition. So the algorithm proves reliable in maintaining accurate results despite fluctuating data distributions, crucial for applications needing real-time analysis. For real-time applications, effective in streaming applications with rapid evolution. So, its effectiveness in real-time or streaming data environments showcase its value in various fields, from ride-sharing optimization to real-time analytics.
So, good day, sir. In my part, I will discuss the algorithm assessment. So, there are two methods of the performance evaluation. The first one is the method of the tournament. So, there are 6 steps to find the KTH greatest element by constructing a structure to a tournament. 1. Make an n minus k plus 2 element tournament. Think of it like a tennis knockout competition. 2. Compare the elements in pairs, as though they were in a match. The victors move on to the following phase. 3. Until you have a single winner, keep pairing and comparing. 4. The KTH largest element cannot be the tournament winner. 5. Think about its route P up the competition. Select one element and trace its way up P to discover the next largest element from the remaining K minus 2 K to 2 elements. The last one is continue doing this until you have used up all of the K to 2 elements. The largest of the tournament will be the KTH largest when the largest is replaced with a negative infinity. So, the method of the tournament gives an organized approach to determining the KTH greatest element by simulating a knockout competition. This method effectively narrows down the elements by comparing them in pairs and advancing the winners. The ultimate selection of the kth largest element entails following the course of the largest elements and examining the elements it destroys. This method is very beneficial when you require a clear, competitive approach to finding the kth largest element with a balance of efficiency and clarity in execution. So, in the evaluation method, there are four methods. So, first one is algorithms with instant optimum for the top k attribute combinations. So, the goal of traditional top k algorithms, such TA and NRA, is to identify the top k items, like restaurants, by combining overall scores from several qualities, like price and location. However, rather than focusing on individual objects, future applications such as query suggestion need to determine the greatest combinations of features. The simple expansion of current top K methods becomes unfeasible due to the exponential increase in the number of attributes involved in enumerating all conceivable combinations. A new kind of the top K query known as top KM has been presented by researchers. Its goal is to identify the top K attribute combination based on the total scores of the top M objects in each combinations, where M is the number of objects that make up a combination. Effective top KM algorithms have been created by taking into account various query certainties such as precise and approximate query processing, and data access strategies such as sorted and random accesses. So number 2 is the quick select algorithm. When attempting to determine which member in an array is the kth largest or smallest, quick select comes in handy. When n, the array size, is not excessively large, it functions nicely. Maintaining a k-element min heap can be an alternative if you have a very big n or an unknown n. Every new element is compared with the top of the heap, and the min heap maintains track of the k largest elements that have been viewed thus far. If it's bigger, the previous top is changed. So, the nature of your data and application requirements will determine whether you use quick select or k-element min heap. Quick select is ideal for static data sets that require a certain order statistic. A min heap, on the other hand, is appropriate for scenarios involving big data sets or streaming data, as it provides a dynamic and memory-efficient approach for keeping top K components. So number 3, CPU top K algorithm. An additional method for identifying the top K components is the CPU top K algorithm, similar to quick select. It employs a special selection algorithm that divides the elements around a pivot. Two vectors are kept track of by the algorithm, one for the original items and another for the chosen elements. It locates the elements that are top K largest and top K smallest. So, the CPU top K approach uses pivot-based partitioning and iterative refinement to efficiently discover the top K components in a dataset. By preserving and updating candidate vectors, the technique provides a flexible and scalable solution for the top K searches. Making it applicable to a wide range of data analysis and resource management applications. So, number 4, top K query evaluation with probabilistic warranties. So, a strategy for the top K query evaluation with probabilistic warranties is presented in this paper. It keeps track of a group of candidates and dynamically modifies the threshold in response to the best results as foreseen. The program evaluates things according to their scores while simultaneously scanning lists. So, the top-key query evaluation with probabilistic warranties provides a powerful strategy for efficiently identifying the most significant elements in a large dataset by maintaining a dynamic candidate set and adjusting the threshold based on observed scores. The algorithm balances computational efficiency with a high probability of accuracy, making it suitable for real-time and large-scale data processing applications. The result. So the output of a top K element method provides a condensed view of a dataset's most significant values, enabling more intelligent decision making, efficient resource management, and insightful data analysis. When using an algorithm and analyzing the output, the specific requirements and application context should be taken into account. The results of a top K element algorithm are the subset of K elements that are, depending on the circumstance, either the largest or smallest in the database. So, so the results, so the results, when you're developing a top K element algorithm, it is critical to consider the application context, special requirements, such as dataset size, memory limits, and the necessity for real-time processing. The output of these algorithms can considerably the out- considerably improve decision-making process in a variety of disciplines, including corporate intelligence, scientific research, and resource management. Organizations can improve data analysis, efficiency, and effectiveness by focusing on the most important parts of dataset. So that's it for my part.
Time complexity. Time complexity, while heap-based methods have time complexity of 0 and log t, certain based approaches have time complexity of 0 and log n. Because heap-based methods are more efficient, they are frequently used for very big data sets. The implementation is simple and effective with a min heap or max heap is used. Space complexity. Additionally, variable is the space efficiency. Large datasets can be efficiently handled via heap-based techniques, which is typically need zero key more space. Implementation. This is a bit more complex, but can be more efficient in certain cases. Heaps are easy to implement, and many programming languages provide built-in support for heap operations, simplifying the processes. Partition-based approach. Quick select can be more efficient for certain cases, but it's more complex to implement. Using the quick select algorithm, a variant of quick sort can also find the top key elements efficiently. Customize and parallelize, parallel customization and parallelization. You can modify the algorithm to find the top key elements according to various requirements, including intricate comparison function or unique sorting orders, to further increase its scalability and boost performance on multi-core CPUs or distribute computing settings. The algorithm flexibility in handling different criteria and its ability to be
parallelize, enhance its scalability and performance, making it adaptable for various applications and large-scale data processing. There are three types of limitation and challenge of top key elements. So here are sorting approach, challenge with large data, finding key largest elements. So to ensure that the first key elements in the array are the key largest element, three elements sort in input to ensure that the first key elements in the array are the key largest elements sort the input array in decreasing orders. Re- rea- Rearranging an array or less of elements based on a comparison operator on the elements is referred to as sorting. Dealing with a big volume of data can be challenging, particularly if it is organized haphazardly. Sorting such data becomes essential at that point. Data must be sorted in order to facilitate searching. Binary search can be used to find key largest elements by defining a search range based on input array minimum and maximum values. In each iteration of binary search, count the largest than the point mid than the midpoint and update the search range accordingly. So this process continues until the range collapses to a single element, which is the key largest element. Quick select. The quick select algorithm is another well-known method for solving key selection issues. While the worst case time complexity is 0 n squared, the average time complexity is 0 n. The latter is dependent on the input size, relative order, and values, but the likelihood is small. Heap-based method provide consistent performance with 0 n log key complexity, making them reliable for large data handling. Implementation. Heaps are simpler to implement using built-in libraries, while QuickSelect can be more complex due to its partitioning logic. It is it is important to realize that although the implementation can be complex, a heap is a very simple tool. In practice, it's essentially just a list that gets sorted each time and implement and an element is added and or removed, which is why we typically represent it why with a simple list or array.
With the population growing rapidly, there is an increasing demand of reliable and affordable transportation. But most customers are often met by a lack of good customer service, while the drivers earn less that you have the best trip possible. And our customers never worry about any electronic manipulation or geofencing.
Affordable ride-sharing app experience with world-class features like emergency alert button, live ride tracking, with several car options to choose 24/7.